Good morning. Today we are going to take a look at cloud-based multitasking system for job scheduling. Before we start, I would like to give credits to few persons who helped me in this project. So I would like to thank Professor Chandrakran's for guidance and support throughout the project. I would also like to thank Anand Gupta for his mentoring activities. And Balasubramaniam is one of my project partner, and I would also like to thank him on this occasion. So cloud-based job scheduler. A scheduler is nothing but it's a system which takes in the tasks from the customers and then distribute the task among the worker nodes which are available. So these worker nodes can be available on the cloud, or it can be your local instances as well. So we have designed various schedulers for doing the scheduling activity of tasks or jobs submitted by various number of clients or customers, and we have designed it to be in a pluggable manner so that if at all a customer doesn't feel comfortable with one of the scheduler, you can just switch to some other scheduler seamlessly. And we want to give more flexibility to the customer standpoint, um, because the scheduler, the customer might me mm, sorry the customer might need different schedulers for different applications. So we have designed some 4 schedulers, and the customers are open to choose anyone as per their preference. So why a cloud-based scheduler? Most of the schedulers which are out there doesn't give control to the customers as to the algorithm which is followed. So they are cornered, or they are pushed to use the schedulers which are available along with the app engine. Also, the application needs might differ from one application to another. So one scheduler might not fit the demands of various applications. This is one of the reason. Another reason is whenever you hear a word cloud, they tag it along with a phrase called pay per use. Let's say you are using some Amazon EC2 instances. You are requested to pay on an hourly basis. So this doesn't exactly stand with the phrase which goes with cloud. So what we thought is that if at all we could model our system in such a way, we could write a wrapper over the existing Amazon AWS services, and this scheduler will act as a mediator between all the customers and then AWS instances. So let's say there is a common pool of worker nodes available. Our scheduler will fetch the task from all the customers and then schedule it on a common pool of worker nodes and then give back their results. Okay, so we have designed 4 schedulers in our system. The first one is FCFS, first come first serve scheduler. Second one is randomized scheduler. Third one is queue length based scheduler, and then the last one is prioritized scheduler. First come first serve scheduler. As the name suggests, it just assigns a task in the order in which it arrives. Let's say there are 2 worker nodes and there are 4 tasks which are coming in. Task number 1 will be assigned to worker 1, task number 2 will be assigned to worker node 2, task number 3 to again worker node 1, and task number 4 to worker node 4. So this is what first come first serve scheduler is all about. Then comes the randomized scheduler. So even this scheduler doesn't have much intelligence built in it, so it just randomly picks a worker node and then assigns a task to it. Queue length based scheduler. So this is kind of intelligence compared to the previous 2. This basically keeps track of length of each queue the worker nodes are consuming from. So whenever a new task comes in, it checks which queue is of minimum length and then assigns a task to it. So in a way it maintains a load balance between all the queues which are available. But this is just in rudimentary stage where we have just considered the number of tasks in the queue, which is again a misnomer in real sense. So we will extend this to calculate the length of the queue based on the execution times of the task in the queue. prioritize scheduler. Some of the needs of few of the customers will be like they want to execute certain number of tasks with high priority. So we came up with this prioritize scheduler, which categorizes tasks into two different categories of low priority and high priority tasks. So we maintain two different queues, low priority queue and high priority queue. So what our prioritize scheduler does is that all the high priority tasks which are come in is sent to both the queues on a round robin basis. But low priority queue, it first checks whether a threshold, I'll just come talk about the threshold in a minute. So low priority task, what our scheduler does is that it checks whether the low priority queue has reached the threshold or not. If it hasn't reached the threshold, we add the low priority task to the low priority queue. And then if at all it has reached the threshold, then we check whether the high priority queue is empty or not. If it is empty, then we add one of the low priority tasks to the low priority queue. So SLA, service level agreement. So service level agreement is nothing but it's a negotiation between the service provider and the consumer, wherein the service provider gives some guarantees with regard to the services which he provides. So here we have given a notion of SLA, wherein we say that our scheduler will give all the high priority tasks will be executed within a maximum of 30 minutes and all low priority tasks will be executed within a maximum of 60 minutes. This is what our scheduler's SLA is all about. Let's take a quick example of how the prioritized scheduler works. As I told, there is a threshold limit for both high priority queue and low priority queue and high priority queue. So in this example, let's be simple and let the queue length be 20 seconds. So the tasks are queued like 1, 2, 3, 4, 5 and 6. 1H represents task number 1 of priority high. So 3L represents task number 3 of priority low. So there are two queues here and I haven't represented any worker nodes. In each queue there can be a number of worker nodes which are listening. So the first task goes to the high priority queue, second task it goes to the low priority queue, and then the third task is a low priority task. So we check whether threshold limit is reached on the low priority queue. Since it hasn't reached, we add it to the low priority queue. Now the fourth task can't get into the either of the queues because the low priority queue has reached the threshold. Sorry, I forgot to tell you one assumption. One assumption of this system is that all the 6 tasks which I have shown here takes 10 seconds approximately. So 4 it can't go into low priority queue because the threshold has reached. High priority queue is not empty, so again the 4 is held in the held queue. Now whenever the execution of second task and first task is done, we capture the event notification and then we move few tasks from the waiting queue to the original queue. So since 2 has succeeded before 1, it triggers 3, and after 1 is done with this execution, it triggers 5. And then when 3 is done with the execution, it triggers 6. So this is what prioritized scheduler is all about. So let's take a look at the performance numbers. So the system is set up like we consider 300 tasks in total. Tasks can be of 3 different types, either 10-second task or 30-second task or 60-second tasks. And so we had 3 different remote workers, all are Amazon instances, and Celery, Redis and RabbitMQ is installed in some other server, and the client application was run locally. So when all the tasks are of size 10 seconds, FCFS and queue length performs almost on similar lines because there is no major difference. Queue length scheduler, it schedules in just fraction of a second, so by the time the first task is completed, all the 300 tasks are scheduled. So almost similar to how FCFS behaves. The randomized scheduler, it's kind of fluctuating. At times it performs better than other two, at times, but most of the time it performs worse than the other two. So one of the advantage of Q-length based scheduler is that if at all we replace the number of tasks with the total execution time of the task in the queue, then when the input is random, the third column which you can see in this graph, when the input is random, Q-length based scheduler will perform better compared to the FCFS. So prioritize scheduler. So this experiment is like again 300 tasks in total. All the tasks are of size 10 seconds. Every task is tagged along with a priority. It can be either 0 or 1. 0 represents high and 1 represents low. So when all the tasks are of high priority, it took around approximately 25 minutes. When all the tasks are of low priority, it took approximately 30 minutes. Similarly, to mimic the real-time scenario, we had 80% low and 20% high. So the numbers are almost on similar lines with 100% low. So this clearly shows that we are giving more importance to the high priority tasks compared to low priority tasks. Okay. So future work, auto scaling. So let's say you are working on your private nodes. You have some 5 nodes, but you don't want to use all the 5 nodes up and running every time. So what you can do, we are planning to come up with a auto scaling scheduler which initially starts with 2 nodes, and then it keeps on calculating the length of the wait queue. Whenever the length of the wait queue increases above a certain threshold, then it spawns new worker node and then assigns the task which are waiting in the queue to the new node. So we are trying to address address the question of effectively using the resources. Then queue length based scheduler, as I was telling, instead of blindly going by the number of tasks in the queue, we are planning to replace it with the execution time. And then heterogeneous nodes. Some nodes in our cloud can be capable of running more complex tasks or compute intensive tasks. So as of now, we don't get any feedback from the nodes whether it is capable of executing certain tasks or not. So in future, we are planning to dynamically detect whether a particular node is more efficient compared to other in terms of specification, and then assign appropriate tasks to it. So okay, these are the references, and that's it from me. So this is our cloud-based multitasking system for job scheduling. Thanks.